we're going to use the definition of the derivative to derive the quotient rule of differentiation. So let Q of x be the quotient of f over g. And we're going to show that Q prime of x equals to g of x times f prime of x minus f of x times g prime of x divided by g of x squared. Now we have already derived the quotient rule of differentiation in an earlier video, but we used the product rule to do so, and then before that we used definition of the derivative to derive the product rule. In this video we'll use definition of the derivative to derive the quotient rule directly. We are assuming that both f and g are differentiable functions, that is f prime of x and g prime of x exist. So let's begin this four-step process of finding this derivative by using the definition. First we'll compute q of x plus h, which is just f of x plus h divided by g of x plus h. That's all we can do in step 1. In step 2 we want to compute and simplify q of x plus h minus q of x, which is f of x plus h divided by g of x plus h minus f of x over g of x. Now let's have a common denominator. The common denominator is going to be the product of g of x plus h and g of x. So it now looks like this. We'll multiply the first quotient by g of x over g of x. So this is g of x times f of x plus h minus f of x times g of x plus h, and in the denominator we have g of x plus h times g of x. The next step, we further want to manipulate the numerator here to make things easier later in the later steps. So we're going to do the following. We take g of x times f of x plus h. We'll subtract f of x times g of x, but then come back and add f of x times g of x. So we did not change the problem. This is just like adding 0, and then minus f of x times g of x plus h, while the denominator remains the same, g of x plus h times g of x. Now notice that these two terms have g of x in common, and these two have a common factor of f of x. Let's factor those out, and this will be g of x times f of x plus h minus f of x plus f of x times g of x minus g of x plus h divided by g of x plus h times g of x. Now we want to turn these around. We want g of x plus h to lead instead of being subtracted from g of x. So we're going to factor out a minus 1, and that will give us the following. It would give us, the first part doesn't change, so it's g of x times f of x plus h minus f of x minus f of x times g of x plus h minus g of x, and this is divided by g of x plus h times g of x. And this is the end of step number 2. Let's go to step number 3. Step number 3 says that we have to take q of x plus h minus q of x and divide that by h. So this is equal to g of x times f of x plus h minus f of x minus f of x times g of x plus h minus g of x divided by g of x plus h times g of x all over h. But remember from basic algebra, a divided by b divided by c, that's a over b divided by c, which is a over b times 1 over c, which is a divided by b times c. We have exactly the same kind of stack here. So this is equivalent of h moving here and multiplying g of x plus h times a g of x. So let's rewrite that, and this is g of x times f of x plus h minus f of x minus f of x times g of x plus h minus g of x divided by h times g of x plus h times g of x. So this is the end of step number 3. Let's go to step number 4, where we actually compute the derivative. Recall that q prime of x is equal to the limit as h approaches 0, q of x plus h minus q of x over h. And so this is equal to the limit as h approaches 0 of g of x times f of x plus h minus f of x minus f of x times g of x plus h minus g of x divided by h times g of x plus h times g of x. So let's break this up into a difference of limits. So this is equal to, we can write it like this. The first is the limit h approaches 0, f of x plus h minus f of x divided by h times the limit h approaches 0 of what's left, which is g of x divided by g of x plus h times g of x. Now, even though we can cancel g of x here, for the formula to come, we don't need to do that. And then minus the limit as h approaches 0 of g of x plus h minus g of x divided by h times the limit h goes to 0 of f of x divided by g of x plus h times g of x. So this limit I'm circling here, that is f prime of x. Now we're assuming that f is differentiable, so its derivative exists. Similarly, the limit I'm circling here is, that's the derivative of g, that's g prime of x. We have one more limit to go. Now because g is differentiable, it is continuous. That was shown in the previous video, which means the limit as h goes to 0 of g of x plus h is equal to g of x. So we can now derive the quotient rule of differentiation. So the first two limits become the following. We have f prime of x times g of x, and then the denominator is g times g, so that's g of x squared, minus, and the second two limits, the ones we're subtracting, we have g prime times g prime of x times f of x, and in the denominator we also have g of x squared. So now the denominator is the same. Let's put this together, and we have just used the definition of the derivative to show that if q of x equals f of x divided by g of x, then the derivative of q prime of x, is equal to f prime of x times g of x minus g prime of x times f of x divided by a g of x squared. And that, of course, is the quotient rule of differentiation. For more videos,